Hello, it's me, Ross from the future. Yes, I am now 26 years of age in such a small amount of time. Anyway, that's besides the point. Today, Gabriel, Raymond, and Ross from the future are going to tell you what happened with our bottle rocket and the physics behind it. Now sit back, relax, and enjoy the next 5 minutes. I know it's boring.
Parabola is the path in which an object or rocket in this matter will take when flying. The parabola is changed by many things. In this case, we are talking about a bottle rocket. So if we put the perfect amount of pressure and the perfect amount of water and design it to fly as best as possible, it will go very far. But if we were to put small amounts of these things, then it won't actually go really far. It can also be dangerous to put too much, since the bottle could explode and shoot bits of plastic that could potentially harm others in a radius. The aerodynamics is the branch of mechanics that deals with motion of gases, especially air. The amount of air resistance that is in the rocket's motion depends more so on the shape of the nose cone. This means that when you start to create your model, you would have a better chance of making it fly with accuracy and precision. This will determine also the wind speed, which affects the flight. So this means the nose cone does not matter at all. It is the components that will keep it together in place so it goes well. The wind speed is the speed that the wind travels at. Wind affects the flight of the rocket drastically. The resistance protecting the rocket from the attacking wind is contingent on the sharpness of aerodynamics and correct modifications applied to the rocket. The effect of wind speed can be withstood by a rocket spinning in the way of a rugby ball that is being passed, because the rocket is spinning and it can cut through the force of the air, keeping the rocket secure. Applying these physics and aerodynamics to our rockets can help it fly longer and farther. Possibly the best angle of flight for the rocket is a 45-degree angle, as it shares the same amount of longitude and latitude with both the x and y axis.
Our theory is that if the cone is more firm, it will go further, as it has it gliding in the air. And if the rocket tip is blunt, it will affect the drag resistance. Drag is one of the 4 forces of flight. The concept behind a bottle rocket like this is that you take a bottle and fill it partway with water and partway with compressed air. Then the compressed air pushes the water out of a hole at one end of the bottle. The force of the water going in one direction causes the bottle to go the other way. Our design of our bottle rocket represents aerodynamic by the bottled rocket's cone, which gives it enough force to be taken by the wind, and parabola, which will hold the angle which it is shot at. This will lead to a successful flight. Our theory was right. Our flight was successful, but we could have gone further if we shot it at a better angle. We were thinking, how would the wind affect the flight of the bottle rocket? This question is the answer to key of unlocking the science and mathematics behind the timing of shooting the bottle rocket. This could help us in further tasks, as this could work out the science of other things that people have been trying to work out.
Hey guys, you're gonna be so happy when you hear this. I'm all better now. In fact, I'm in the doctor's office right now. He said I had a case of dumbness and I needed to treat it ASAP. So he gave me a medication called Bok. Or was it Book? I think it was Book. I can't remember. And now I'm feeling all better. My tongue is fine now. I know you guys were worried about me. It wasn't even a bee after all. So I guess this is where it ends. Thanks for spending 5 of the most important minutes of your life to watch our clearly amazing video. Later.